question 4, and this question is about solar panel. Question is simply asking us select and explain features of the solar panel to maximize the final temperature of the water. Here is copper pipe that is painted black. We are also using sheet of glass, and here is also metal sheet that is also painted black. And insulating material we are using under copper pipe and air trapped. And so how these features, for example, how these features means why we are using copper pipe, not using any other pipe made of rubber, pipe made of plastic, why we are not using those type of material, why we are using only copper pipe. There must be some reasons, scientific reasons, logic behind. So why it is painted black, why it is not painted white. And insulating material, why we are using insulating material, not conducting material. Air trapped, if air is trapped, what is benefit of that? To increase the temperature of hot water. And also here we have metal sheet, why it is painted black. So these are the features, and now we need to select them, means we need to mention the feature, and also we need to explain, means what is its role in increasing the final temperature of the water. So let's answer this question now. So this is how we can answer this question. So you can see here, first of all, I have mentioned copper pipe. This is one feature, and why we are using copper pipe? Because it is a good conductor of heat. If material is a good conductor, so good conductor, we need to understand what good conductor means. Good conductor simply means that material can conduct heat quickly and easily. Conduct heat quickly and easily. So this is benefit of good conductor, quickly and easily. The second feature, black surface. Why the surface of copper pipe is black? Because black surfaces are good absorber. It means they can absorb more heat, and they are poor reflector. It means they will reflect less heat. The third feature, trapped air. We can also talk about this one. If the air is trapped, it means there will be less heat loss due to convection. And fourth one is insulating material. Why there is insulating material under this copper pipe? Because it will reduce heat loss. And fifth one is glass. Glass, here you can see we are using this material, and this one is made of glass. Why we are using glass here? Because glass produces greenhouse effect, mean it stops radiation from escaping. For example, if the radiation go after glass, it will be reflected back. So means here glass produces greenhouse effect, and due to greenhouse effect, temperature of copper pipe, or means the temperature of water inside copper pipe, will increase more. So this is how we can answer, and this part A has 4 marks. Let's move on to part B now. Part B is about calculations. So what is given to us in this question? It is given to us mass of water is given, and the temperature rise is given, means this is delta T is given to us, and the specific heat capacity of water is also given, so the C is given. So let me explain you one very important point, means the key concept. Let me explain to you. So this key concept we can simply understand like this. Let's say the 4 rays of light, 4 radiations are falling on this solar panel. So this is our solar panel. So how many of them are reflected back or not absorbed? So according to given informations, if 4 radiations are coming, so only 1 is absorbed. It means that only 25% is absorbed, or we can say 1/4. Now this is very important, because this is kind of common problem for many students to find out energy incident. They can find out how much energy is absorbed by water, but sometimes they just get stuck. They don't know what's going on. So if you have this idea, you look at this diagram, you will be quite confident to answer this question. So let's answer now. This is just simple use of formula mc delta t. This one is the mass, here is the c, and here is delta t. Delta t means that 38 minus 16. So we got 22. We don't need to convert to Kelvin in this case because the change is the same. The change is the same. Delta t is the same in Kelvin and also in Celsius scale. So if we calculate, this is the amount of heat absorbed by water. Next one, energy incident. As I explained to you before, if we need to calculate energy incident, we just need to multiply by 4 because this one is the 25%. We need to calculate 100%. So we just need to multiply by 4. So if we multiply by 4, this will be our final answer. The total amount of energy incident on the solar panel. So you see how we just need to find out how much energy is absorbed and the total energy, then we can just multiply by 4 and we can calculate. Let's move on to next one. Part C. We don't need any calculations. So this question we can just do without any calculations. Question is asking us list and explain 3 pieces of informations if she needs to consider in order to make her decision. And we need to help this person now so she can decide easily. So first thing, for example, when you are going to install solar panels, we need to consider is the light, the sunlight is enough there or not. The second thing, the cost is very important. Also, we need to consider our needs in the solar panels. How many solar panels we need to install so it can meet our needs. So these things, if we have in mind, we can answer that. Let's move on to our answer. So this is how we can answer. First thing we have to consider which direction roof faces mean. Is the light is enough there or not? If there is any shade, if the roof is shaded, it means it's not good to install solar panels. We also need to estimate the output of the panels. How much is the output? Can it meet our needs or not? So here is also the next one, household needs. So we also need to consider. The last thing we have to consider the cost of installation. So do we have enough money to install or not? The last part of question number 4. This question is simply asking us what is meaning of nuclear fusion. Nuclear fusion. So nuclear fusion simply means that two small or lighter nuclei, they combine together and they form a big nuclei. Big nucleus, simply I can say. This is mean lighter nuclei combined to form heavier nucleus. So this is how we can answer. Lighter nuclei join together to form heavier nucleus. So this is how we can answer question number 4. Let's move on to question 5 now. Question number 5. Question number 5, you can see here we have a piston. So this is piston and here is cylinder. So this is cylinder. And also this length is given. This is 100 centimeters. And pressure gauge is also installed on this cylinder. Now what we need to answer? We need to describe the motion of the molecules of the gas. So the value of P is given to us and cross-sectional area is also given. So how we can answer part A now. Part A simply is asking us describe the motion of the molecules. Motion of the molecules simply, this is a very common type of question. We need to understand molecules move randomly and they collide with each other and also they collide with the walls of the cylinder. So this is very simple one we can answer. The next one, use the idea of momentum to explain how the molecules exert a force on the walls of the cylinder. So first thing we need to understand using the idea of momentum and force. So we need to understand what is relationship between momentum and force. So force is equal to delta P over delta T, means simply rate of change of momentum is called force. This question has 2 marks. So let's try to answer how we can write a proper answer for this one. So here this is how we can write the final answer. You can say the proper answer. Collisions with walls will cause change in momentum of molecules, and rate of change of momentum is equal to force. If we write these 2 points, we will get 2 marks. Next one. Here is our part B. Question 5, part B. Question 5 is asking us, now the cylinder is, the new length of the cylinder occupied by the gas is only 40 centimeter. Before it was at 100. Now the cylinder is at 40 centimeters. Means the cylinder is means the piston is at this point now. And this distance is 40 centimeters now. So, and in other words, we can also say volume is decreased. Means the volume has been decreased. So volume is decreased. So this is one thing we need to understand. Volume is decreased. So it's asking us calculate the new pressure of the gas. So this is quite straightforward one. We need to use P1 V1 is equal to P2 V2. All the informations are given in previous part. We just need to plug in values here. One thing we need to understand is that as the cross-sectional area is the same, so we simply understand volume of a cylinder that is equal to cross-sectional area times L. So if area is the same, so we can simply consider L. This is simply Boyle's law, very common formula. This is the formula you need to remember this one. So this is P1 V1. So you can see this is the volume actually. Even here we just use L because on both sides this one will be cancelled because this is the cross-sectional area and this one is the L. So here again this is the volume, this is V2, and what we need to find out, P2. So if we just multiply and we simply solve, we will get our final answer. So this is new pressure. It has to be increased than before because as volume decrease means PV is equal to constant according to Boyle's law. So this is simply our Boyle's law. PV is equal to constant. So simply you can see if volume decrease, P has to increase. Let's move on to next one now. Explain in terms of the behavior of the molecules why pressure has changed. As I mentioned before, as the volume has been decreased now, this is very common misconception among many students. They think that when the volume is decreased, it means the speed of molecules increases. No, speed of molecules only increases if the temperature increases. So in this case, temperature is not changed. Given to you, temperature of the gas is unchanged. It means the speed of molecules is not changing. So now the space has been decreased. Now it means the molecules will hit the walls more often or more frequently. So this is the keywords you need to understand. If the volume is decreased and temperature does not change, it means molecules will hit the walls more frequently. So this is the point you need to understand. Now let's try to answer how we can write our final answer. So here is our final answer. Molecules collide with the walls more often or more collisions per second. So if more collisions per second means more people they're pushing the walls at the same time, so it means greater force per unit area. So more often they apply force again and again. So it means greater force per unit area. If the greater force per unit area, so simply we understand P is equal to F over A. If the force increase, it means P has to increase. So this is how we can answer question number 5. Next is question 6. Question 6 is also kind of typical question at IGCSE level. Let's try to answer this question now. The first part simply is asking us, we need to draw the pattern of the wave fronts after the wave has passed through the gap. So how we can answer this one now? So before we answer this question, we need to understand this is the wave front. So this line, horizontal line, this represent wave front. and the distance between two wavefronts. This is equal to lambda, means the wavelength. So this is wavelength. So we need to be quite clear about this. As we can see here, the water is on one side, and after it crossed the barrier there is also water, means the medium is not changing. If the medium is not changing, let me write down the frequency, that is equal to V over lambda. Frequency, we need to understand, it depends on what? Frequency, it depends on source, and velocity, it depends on medium. It means if the medium is the same, speed of wave is the same. Speed of the wave is the same. If the speed increase, lambda also have to increase. If speed doesn't change, wavelength will also not change, and also vice versa. If the speed decrease, wavelength also decreases. Now as the medium is not changing, so the wavelength will not change because the speed of the waves will not change. So this is how we can answer. So what we have to be very careful is over space, actually space between these lines. It has to be same as before barrier, and it also has to be same after barrier, because wavelength here, let's say speed is v1 here and speed is v2 here. In this case, v1 is equal to v1, v2 is equal to v1, and lambda 2 is also equal to lambda 1. The second thing we need to understand is that we need to draw at least 3 wave fronts, not 1, not 2, at least. So how many wave fronts you have to draw? At least 3 wave fronts to get full marks. Part B is simply asking us calculate the frequency of the wave. So what is given to us? The wavelength is given to us, means the lambda is given. So its value is given in centimeters, and the speed is also given, V is given in centimeters. We need to simply calculate frequency. The units, you can see the wavelength is in centimeters, speed is also in centimeters per second. So simply we can calculate frequency. So this is how we can calculate frequency. So simply frequency is speed over wavelength. So simply centimeter will be cancelled with centimeter. We will get, this is our final answer, 8 Hertz. We can also write down, because this has 2 significant figures, we can also say 8.0, means we can also write down this is 8.0 Hertz, or we can also say per second. This is what happens to the frequency. We have already discussed frequency depends on the source, and frequency is equal to V over lambda. As the source is not changing, so it means the frequency is not changing. So this is our answer, no change. Here is the last part, part D. Let's try to answer part D now. So what this question is asking us, this is the first thing we need to understand. Explain in terms of diffraction. May pick up low frequency radio signals but not pick up high frequency radio signals when the car is traveling behind a hill. And the physics we need to understand to answer this question is simply diffraction. Let's say these waves are coming and we have a barrier here. If the gap size, means this gap size, if this is almost equal to the lambda, to the wavelength, when the lambda is almost equal to the gap size, so gap size means this is the gap size. So in this case we have significant diffraction. So this is one thing we need to understand. Significant diffraction occurs when these two are almost equal. So there will be significant diffraction. But if we decrease the sign, if we decrease the gap size, now let's say we have the same waves, they are coming. Now if the gap size we decrease, so in this case there will be more diffraction. If the lambda is smaller than, if the lambda is bigger than, means the lambda, the wavelength, for example, if it is bigger than gap size, there will be more diffraction, bigger than gap size. So we can say more diffraction, or waves will bend more diffraction, waves diffract more. As we understand, the size of the hill is very big, so it means if the wavelength is bigger, there will be more diffraction. So we will simply say if the wavelength is longer lambda means that in this case there will be more diffraction and it will be easy to receive signals. So if we have understanding of these points, then it's quite easy to answer this question. So let's try to answer how we can write a proper answer or our final answer. So this is how we can write down our final answer. And we need to say that is the low frequency. If the frequency is lower, it means wavelength will be longer. If the wavelength is longer, it means there will be more diffraction. So that's the reason it is easy to pick up low frequency signal as compared with higher frequency signal. So that's all for this video, and I hope this video will help you to understand question 4, question 5 and question 6. That's all for this video, and remaining 4 questions, I mean question 7, 8, 9, 10 and 11, means 5 questions I will cover in next part.